Okay. Right. So let's start our lecture this morning. So I will be recording. Okay. So we've talked about the subnetting and VLSN, right? That is meant for IPv4, and we understand that the reason why we do subnetting is because we don't have enough IPv4 addresses to go around. Okay, it used to be, but currently all the IPv4 global IP address are depleted, right? So they basically divided the address range between public and private, right? So for the public-facing IPv4 addresses, you don't subnet, right? So basically, they're reusing. Okay, they're reusing, and therefore, a large portion of addresses that you see globally, basically, there is three ranges that are available for the private addresses range. Okay, the one with starting with 10, the one with 176, and the range with 192. Okay, so these are class A, class B, class C type of addresses, and it is these even the private address range are not sufficient, but because we can hide them, yeah, within our own organization. So every organization potentially have these three ranges all to themselves to use, because private addresses are not routed beyond the local gateway, the router, okay, for each LAN. So even if an organization has many, maybe it's a large organization, so they have many LANs, all right? So each LAN could potentially use the same private addresses, but because these private addresses does not go beyond their own LAN, it's not routed by the router, so there's never any conflict. All right. So the problem is, we even with the individual LAN, we might need a way to save the range of addresses. That's where subnetting comes in. So subnetting is basically a concept where we divide private addresses. Okay, so we've learned, because there are three address range, the class A, class B, and class C, which is /8 prefix, /16 prefix, and /24 prefix. Okay, this prefix indicates how many bits belong to the network portion, right? Therefore, we also learn to do subnetting for class C, okay, class B, and class A, right? And what we've learned is that for class C is easier because the number of bits, okay, that we are dealing with are smaller, which is only one octet. That means maximum 6 bits you can borrow. So the the values that we are working with are smaller. So that there are not many subnets you can create. Okay, and the number of hosts per subnet is also small, right? But maybe this is insufficient. So we go to class B. Now class B, because the network portions are only 2 octets, therefore we have 2 octets for the host. So there are more bits, potentially more bits you can borrow. So the maximum for class B, basically 1 octet 8 plus 6 from the last octet. So 8 plus 6 is about 24 bits. You can borrow up to 24 bits. Right? So the process is the same for the subnetting, but the values you're dealing with are larger. Okay? Okay? So, but the process is the same. The technique is the same. It's just that you have to be mindful that there are more subnets that you can create, and there are more hosts per subnet, right? Then finally, we go to class A, and class A has even a larger range of subnets you can create, because now that we are dealing with class A, address starting with 10, right? So potentially, because you have 3 octets belonging to the host, potentially you can have 8 plus 8, which is 16, plus 6 is about 22 bit, right? Before is 8 plus 6, 14 bits. Okay, so you have more subnets you can create, right? And depending on how many bits you bought for the network part, then potentially you can have a large number of hosts per subnet. Okay, so subnetting. But then we figure out that even though we subnet using this technique, because all the subnets are equal size, we basically divide the network into equal size networks. Sometimes our requirement, the organization requirement is not matched closely, because not only we have to figure out how many subnets we want to provide for the organization, but how many hosts or usable hosts that we want to provide per subnet. That's why after we know how to do subnetting, we learn how to do VLSM. VLSM allow you to not only divide a network into subnets, but you can then pick one of the, after you do the subnetting, you can pick one of the subnets that's available, okay, that's not being used, and further subnet that subnet. By subsequently subnetting, you can basically get close to the number of usable hosts required per subnet. And different subnets may have different host requirement. Okay? Right, so it's all complicated because this is what you have to do if you want to stretch the usage of IP version 4, right? And we have looked at the reasons why IP version 4 is transitioning to IP version 6. The reason why, mainly due to this, but there are other reasons, okay? We discuss about it, right? But we also noticed that the transition is quite slow. Okay, we also discuss why, mainly because we cannot force organization to immediately transition. That means switch over from IPv4 to IPv6, right? So IPv4 is, I think, will still be with us, okay, in the foreseeable future, but more and more organization transitioning to IPv6. Now, when before we move to the IPv6, I remember I asked a question to you guys earlier on. Okay, I don't know whether you remember the question I asked. Why do we have a big jump from IP version 4 to IP version 6? Okay, what happened to IP version 5? Have any of you went on and Google the reason?
No.
No.
No, Farah?
No,
Strange,
not really.
right? Strange, right? You guys not curious at all? What happened to IP version 5? Why IP version 6 straight away? It's like you jump a version, right? In fact, they did not jump a version. There was a proposal for IP version 5. This was earlier, okay? Earlier on. Okay, when they start to think about they need to, they need to come up with the next internet protocol, okay, after IPv4, they did suggested IPv5. So the discussion started. There was public papers coming out, right? But then at that time they're not looking forward enough, because the technology wasn't there. Okay, the technology wasn't there to indicate that the and also that time the depletion of IPv4 addresses was not that acute. Still okay, you know. So the proposal for IPv6 was actually still using 32-bit because IP version 4 was 32-bit, right? So the next version, IP version 5, they want to improve, but they didn't focus on the address range depletion because I think at the time there was still enough to go around, and there was no technology in terms of IoT, right? Networks, infrastructure around the world still, not matured. There are not many. That means it's not as large as the internet right now. But they did consider about improving certain aspects of IP version 4. So because IP version 5 was designed around 32-bit, by the time it's not implemented yet, so they were proposing it. By the time this thing take time. By the time they wanted to do something about it, they found out that, or they figure out, and there was a discussion that 32-bit is actually too small a range. Okay, so I think they decided to not continue with IPv5 rather than modify everything in IPv5 because it basically your your protocol depends on how many bits you have for the address. They straight away proposed IPv6, and this time they don't want to make the same mistake. From 32-bit is a big jump, right? From 32-bit all the way to 128-bit, right? Okay, so that's one of the major reason why IPv5 was never took off, right? Okay, and it skipped, right? So when they design, whether it was for I think I'm not sure for IPv5, but for IPv6, one of the things that they don't want to have is doing network address translation. This is a big problem because network address translation translates public address to private addresses, and then private addresses to public address, right? So this is the thing that they do not want to have for IPv6, right? But there are some people still think that okay, but we still want to hide our network. So therefore, it may still be a good idea. So what I want to share to you now is the paper, not this one, yeah. Let me just get the request for comment, right? Just gonna share that. So basically, this document may not be part of our um, syllabus, but it helps you understand the fact about the subnetting part, okay? Because I want to talk about the subnetting part in the IP version 6, right? We still have subnetting in IP version 6, but not because of the reason that we think of, right? Not because of the reason why we have it for IP version 4, right? So if you want to read further, okay, so that you have a deeper understanding, you can click on that. That's request for comments. Usually, a lot of this open standard, okay, they release request for comments to explain their decision for certain aspect of the protocol, okay. Right, so here you can see that all this is an abstract. You can, if you read, I'm just going to quote it. Although there are many perceived benefits to network address translation, its primary benefits of amplifying, or it means, okay, even with one global IP version 4 address, okay, it basically able to support whatever range of private address space that you have inside your own local area network. You can see that its primary benefits of amplifying available address space is not needed in IP version 6. In addition to NAT's many serious disadvantages, there is a perception that other benefits exist, such as variety of management security attributes that could be useful for Internet Protocol site. IP version 6 was designed with the intention of making NAT unnecessary. Right? So you can further read how the request for comments article talks about the reasoning, okay? The reasoning behind that, okay? And with that, I want to start our lecture this morning. Design consideration for IP version 6, right? In terms of subnetting, right? Okay, subnetting and IP version 6 network, right? So bear in mind that we are not subnetting in IP version 6 network because there is not enough address space, right? That is the main reason we do it in IP version 4. But we do still subnet in IP version 6 network because due to organization structure, right? So again, one LAN is with all the problem about broadcast domain still available in IP version 6. And all the arguments about an organization wanting to have different LANs for different purpose within their organization still stands, even though you are using IP version 6, because these considerations are business or policy, business policy or organization policy considerations. All right. So we still want to do subnetting, but now it's not variable length. Recall that IP version 6 is an 128 bits network address. So we have the global routing prefix that is used to provide the IP version 6 global unicast address. Okay, and it's reserved for 48 bits. And usually this global routing prefix is provided by your regional internet registry or RIR. Okay, so if you're a large enough organization, you may request, you have some cloud because you're a very large organization, so you can request directly from RIR. That's the organization that looks after the address space for the IP version 6 and also IP version 4, yeah, mind you, for each region in the world. So if you're not that large that you need to deal directly with RIR, then you deal with your ISP. The ISP is large enough, and it's in their interest to actually get the range of global unicast, global routing prefix from the RIR. So if you go by that route, you can either go direct or you can go by your ISP. So 48 bits is reserved for global routing prefix, and a 16-bit portion is reserved for subnet ID. Recall also, when we talk about the format of IP version 6 address, that subnet ID is provided and it's managed by the organization itself. So you get your global routing prefix from your ISP, for example, but the ISP do not have any say on the subnet ID. So the subnet ID is used by the organization to provide different network. So you have 16 bits. So with a 16-bit, you can use the same formula 2 to the power of n being the number of bits, to see that how many subnets you can create. And for each subnet, right, after you assign the subnet ID, you cannot then subnet it again. So the prefix stays the same. In this case, it's /64 network, okay, 48 plus 16 bits. So the subnet ID provide the differentiation, okay? Even though you only have one global routing prefix provided to your organization, you can then create many networks. Each network or subnets is differentiated by this subnet ID, right? So you have 2 to the power of 16 possibility or possible subnets. And each subnets will have how many hosts? Okay, to the power of 64, right? And that is more than enough hosts per subnet. So again, we are in the situation where we do have enough bits that we can afford to waste them, right? We can afford to waste them. If you look back through your slides, you can check how many zeros you have for the undecillion. They call it undecillion the number when we reach 128 bit, right? Okay, so 2001, I believe it's a global unicast address. This is routable on the internet. Okay, so given the 2001 DB8 ACAD slash 48 global routing prefix, of course, to make up to 64-bit, there's a 16-bit subnet ID. Okay, and you are if you 2 power 16, you see that you have 65,536 subnets you can create. That means that you have around about 65,000 networks. Okay, if you're with only one global routing prefix, okay, with the differentiation given by the 16-bit subnet ID, you can have that many subnets. Okay, so that's a lot, 65,000 networks. Okay, so here indicates that the global routing prefix is the same for all subnets. So that means your ISP will give you that global routing prefix and you differentiate your own network. It will be your own network because your global routing prefix will be the same because it's the only one given by the ISP to you. And then you differentiate your network by varying the subnet ID. So starting with 000, you go to 001, 2, 3, 4, and so on until you get 65,536 subnets, right? So per subnet, you have the remaining 64-bit interface ID that is used to differentiate hosts. Okay, okay. So the host part you will increment per subnet. You want to create subnets, you increment the subnet ID part. Okay. Okay, I remind you, if you have any question, feel free to ask the question to me. Yeah. Right. Okay. Right. So let's have a look at an example of subnet allocation for IP version 6. So here you can see a diagram, a topology diagram, and we can count how many subnets it requires. So starting from the top, let's have a look. We can have one here, 2, 3, 4, okay, and 5. So there are four local subnet, okay, 4 subnets, and then one wide area network subnet. Okay, we normally assume that this point-to-point between routers is a wide area network. Okay, it could be, but it could be linking between buildings. Okay, it could be linking between floors, or it could be linking between the same floor but different networks within the same floor, or it could be linking two separate branches. Okay, okay, depending on the scenario. But you can see here from the topology diagram, it's not, this is logical topology diagram, so it doesn't show physically, yeah? Okay, we just look at it in terms of the logical aspect, the logical topology. Okay, so we want to create about 6 subnets. Okay, and again, we use the subnet ID to differentiate. So we pick subnet ID starting from 1, okay, until 5 to allocate to this configuration. Okay, so we can see that it's the 48-bit part, routing prefix, the global routing prefix are all the same. Okay, differentiated only by, well, here is a compressed format. Remember, leading zeros will be um, removed. And also, because it's a network, the host part all 0. Recall all 0 is network, right? So this compressed format, you should be able to read it because we already learned how to compress using the two rules, okay, for IP version 6. So you can see the leading zeros of the subnet ID is omitted, and so is the zeros representing host part are all omitted as well, leaving behind the 2 columns. Okay, so these are compressed format. Yeah, here semi-compressed because subnet ID is expanded to show you the full 16-bit, but this part, the host part, is again compressed. Okay, so hope you guys still remember how to do the compression. Yeah, right. So you can see here highlighted in red. Okay, subnet ID 1, 2, 3 is here for the wide area network. 3, 4, 5. So 5 subnets and 5 subnet IDs created from 1 to 5. Okay, so because we have the 64-bit belonging to the host part, each subnet definitely will have more addresses than you ever need. Power 64 minus 2, and you can see that it's going to be a lot, right? So but again, because we have so many such a wide address space, we can afford to be a bit wasteful. Okay, right. So in this example, we are looking at the device, okay, router 1, which is I think is it indicated here. It's not really indicated here. Maybe this is assumed to be router 1. But if you go to any of the router, you need to assign the address, right? So this is example for router 1. Now, we pick the gigabit 000, gigabit 001, and also the serial interface 010. And for each of the interface, you assign the IP version 6 address, okay, with the prefix. Okay, so for IP version 6, recall that there's no subnet mask because it's already indicated as the slash prefix. Again, remember to type no shutdown to bring the interface up. Okay, and then exit, going back to config, and proceed with providing IP version 6 addresses to the other interfaces. Okay, so same in terms of configuring the interfaces with address is the same as before we've learned in packet tracer, right? Right. So as we discussed earlier, our subnet team for IP version 6 is not concerned with address space or conserving or trying to minimize the wastage. Okay, remember we have 64-bit interface ID, definitely would be wasted, but we fix it because that's not the point of subnetting in IP version 6. Okay, right? So the point is, we still want to have some kind of structure for our network, or hierarchical structure. Okay, that means we want to subnet because of other business policy reasons. Yeah, we want to not to have one single LAN where everything is just put there together. So we want to create multiple subnets. Each subnet serves a different purpose. Okay, right? That's why it says here it's about building and addressing hierarchy based on the number of subnetworks that the organization needs. Right? Okay, so recall also that IPv6 has many addresses. Okay, we can have this example here with the global routing prefix and subnet ID. This is an example of a GUA, the global unicast address. But we also have link local address. Link local address is never routed beyond the gateway. Okay, cannot be routed by the router to outside of your LAN. Link local means it stays inside your subnet. So link local address, okay, is another address. So you can, by now you will realize that an interface for IPv6 can have multiple addresses, or multiple IPv6 addresses. One of them that must be provided, even if you don't provide the global unicast address, is the IPv6 link local address. Okay, and once you assign a link local address to a particular computer or host, it will never, you cannot subnet it further. That means link local address is not subnetted. Okay, only the global unicast address can be subnetted, and this, what we're talking about earlier on, is how we subnet a global unicast address, right? So you can see the prefix 64, right? So divided between 48-bit, 16-bit, and then 64-bit for interface ID. So the network part is the 48 and plus 16 bits. So this is a slash 64 prefix. 48 bits provided by your ISPs, and the subnet ID created by you yourself as the organization to differentiate different subnets. When you want to create more than one subnet, you have multiple subnets, then you make use of the subnet ID. Right? Okay, so this is the part of the subnet ID 16-bit that you can manipulate. Organization can manipulate this one. Okay, and you can take any subnet to assign to your subnet. Okay, so the range is up from 000 up to FFFF. Okay, the last subnet. Right. So you can see here that what we did earlier. Okay, we assign for the subnet, and this is a configuration for I imagine one of the router.
Sir,
Yes.
the one the slash 64.
Yeah. Slash 64.
Does
Yeah.
that does that represent the network?
Yes. Represent network. 48-bit global routing prefix, because you can see 2001 is a global unicast address. Okay, so the global unique part provided by the RIR. Okay, and normally our organization has to be very big to actually get directly from RIR. So usually for smaller companies or smaller organizations, they get from ISP. Okay, so the range already given to ISP. And then the ISP will, from the pool of global prefix they were given, they will assign to the customer, which is the organization. So let's say your organization. So you apply to this ISP. You say you want a global address. So they will not give you the whole 64-bit. They give you 48-bit because the other 16-bit is given to you to allow you to create more than one network to subnet. That's why 48-bit belongs to the global routing prefix. Is the one given by the ISP to you. They give you only one, right? So even with one, the network portion includes the 16-bit subnet ID. Okay, the 16-bit subnet ID is configured by you, the customer, right? So that you can have more than one subnet. So because you have 16-bit, you can create up to 65,000, okay, around about 65,000 subnets for yourself, okay? So because this provide the differentiation, this prefix plus this subnet ID means it's a network address. So you can see the differentiation here, yeah, allowing you to have even with a single global routing prefix, okay, you can have one subnet, two subnet, three subnet, because you can see it's different because you differentiate via the 16-bit subnet ID. Okay, so the whole 64-bit is 48-bit global routing prefix here, given to you by your ISP, plus your own part subnet ID that you can play around with, yeah, about 16-bit. So 48 plus 16 is 64-bit. So 64-bit is the network portion. You can see, yeah?
So if
Right? Is that
for
okay?
IPv6, is there any like class A, class B?
Oh, we're not
Whatever.
thinking about classes anymore, right? But we are thinking about, we still want to provide subnets. Okay?
Oh,
At the early part I was talking about, subnetting is required by to do in IP version 4 because we want to increase. Okay, it's only on the private network range. We want to increase the number of subnets because the private address range also very small. Okay, sometimes you cannot create that many networks, especially with the range we have. So that's why we do the VLSM. But the main purpose in IP version 4 to create subnet is to provide more addresses. Okay, but in IP version 6, even though we have undecillion range, there is still a purpose for subnet. But the purpose is more towards organization. How you organize your networks inside your company or inside your institution or organization. It means how you manage your network, right? So there are other reasons. There are many reasons why we want to create multiple networks, because maybe we want to follow our functional area in our business, for example. Human resource, one network. Sales, one network. Management, one network. We want to separate them. Okay, so that means in IP version 6, even though we have so many IP address, but we still need to provide subnets. So this is the way we provide subnets within IP version 6 network. Notice that we don't have to borrow base over, because when right now, this is how they do it. 16-bit is given to the organization to provide subnets. So you can create up to 65,536, I think, yeah, subnets. Right? So together they form the /64. Okay, the 48-bit given by the ISP, and the RIR give a range to the ISP. The ISP take one, give to you as a customer. Then the 16-bit, you manipulate yourself, okay, and decide which subnet ID you want to give to which subnet inside your organization. So still subnet, but now no longer thinking about class A, B, C. There's no classes, right? Does that answer your question?
Oh yeah.
Okay. So the link I gave earlier, okay, in the chat, is the request for comments. In that discussion, in that article, right, they discuss this consideration about subnetting within IP version 6, where they do not want to use the network address translation. Okay, because they said network address translation, there's problems with it. So if there's anybody, any organization saying that, hey, hang on, but this network address translation is also good for provide these other things. So in that article, they say, okay, if you want that other thing, actually IP version 6 also have features inside that can cover that, right? So we're not going into that area. It's beyond our syllabus, but as a curiosity, if you guys want to read what is the discussion, okay, for deeper understanding, you can read that link just now, the request for comments. Okay, I just want to make another thing clear. We subnet the private address range in IP version 4. Here, the subnet is the GUA, Global Unicast Address. Can you see the difference? IP version 6 wants to provide end-to-end from host to host without any NAT. So all of this, okay, because the network portion are given already, and then here all the addresses here are all GUA, because this is global routing prefix given to you by the ISP. So this make this address range, yeah, all internet capable or internet unique for the internet. Okay, and once the ISP assign this to your organization, then this is globally unique because this is global routing prefix. The /48 is a global routing prefix, means it's global, unique globally. So there is no need for network address translator or translation anymore, because now this address is internet capable. Right now, if you go to ISP, okay, they will give you one IP address only that is global. Then you're using private address range and you're subnetting that inside your LAN, and the translation between private to public is done by the network address translation in your router. So there is never an end-to-end. Only the interface on the router facing the internet is actually global. Can you see that? But here, because when you apply internet address, they don't give you a specific IP address. They give you, the ISP give you the global routing prefix. This is the 48-bit. Okay. Then you have 16-bit to play around with to create subnets. So there's no subnetting being done anymore. Using this, you create your subnets inside your organization. And each subnet is available to power. If here interface ID again is ensured to be unique, right? There's no clash globally because this is already unique, globally unique, assigned by the RIR, regional, I think, internet registry. Remember the picture of the atlas where you have five regions, ethnic, ethnic, and all this, right? They are the same organization that going to provide all these IPv6 addresses. How they give every organization or ISP global unique address is this one. They just provide the range of global routing prefix to the ISP. Then ISP will take one, give to you if you're a customer. Okay, and then you as a customer will make use of the 16-bit leftover, the not given by the ISP. So this one you can play around with. If you only have one network, you just use the 0000. If you have more, then you can use 000, 001, 002, and this part make this even though it's only one, make it more unique again. And within each subnet, you have 2 to the power 64 minus 2 hosts, and each interface ID part, you can see in our previous lecture that you can use the EUI64 or the random technique to create the interface ID. And in IP version 6, there is a protocol, okay, that runs inside the subnet to ensure there is no duplicate address, right? So there's a lot of protection in terms of not having duplicate address. So we do subnet, but now we're subnetting the global unicast address. Okay, what about private addresses? We still have, it's called the link local. Okay, where's the, I think link local address, shit. Link local address is available, which is never forwarded by the router. Okay, just in case you don't have global unicast address, then at least you can communicate within your own LAN using the link local address. Now, this link local address is not routable by the IP version 6 capable router. It will only route the global unicast address. So if your in your network, okay, you didn't subscribe to ISP, no connection to, or even if you subscribe, you don't want to give this subnet access to the internet, then you don't assign this address, the global unicast address. You only assign link local address. Mind you, every computer or every host within a network, IPv6 network, must have a link local address. So by default, all hosts within a LAN is able to communicate to each other because of link local address. Okay, link local address, you can view again the different types of IPv6 addresses slide, how the link local address is created. Okay, inside right inside your own subnet. If you need to communicate outside of your own LAN, you cannot use link local. Then that's when you need to get this from your ISP, the global routing prefix. Okay. If you're a home user, you probably will not use the subnets 00005 version 6. But if your organization, you might have more than one subnet, so you then can use the range from 00 to FFFF to differentiate your subnet. So it is /64 prefix because 48 plus 16. Okay, becomes 64. 48 given to you from ISP. The 16-bit you can manipulate how you wish. Okay, you have a range between 000 to FFFF as the range of subnet IDs you can assign to your internal network. But because each computer inside your subnets, okay, you created, has this global routing prefix, means the computer is globally connected. It is actually the public IP address for IP version 6. So this allow IP version 6 to omit network address translation. There is no need for network address translation anymore. There's because it's not private address. And you can have so many. Think here 2 power 64 minus 2, that is interface ID per host. So that's a big number of hosts per subnet. Because this is global, whatever you do here and did here is still global. Is that okay? Does that make sense to you guys? Because this part is global, globally unique. So no matter whatever you use here as an organization or individual, and here, that address is global because of this 48-bit is global. This is unique global.
Okay.
Okay, so think about it. That means if you apply to ISP, they give you this. So every computer you assign is using global IP version 6 address. That's the beauty of the IP version 6. No longer need translate between private and public. There's no need because potentially you can have all globally global IP version 6 address. And from the ISP point of view, they don't have to worry how many computers you have. They just give you your global routing prefix, and you manage this part, you manage this part, right? And that makes all your addresses just based on this. All your addresses will be globally unique. Will be able to be routed on the internet because of this global routing prefix. This is the only thing you need from your ISP. Okay, then you can, from this, you can create around 65,000 subnets, which each subnet having 2 to the power 64 minus 2 IP addresses, and they are all globally unique. It's overkill for individual. If you're given this by your ISP, I don't think you can finish up the address range. That's why I said because of the undecillion range. Remember, RIR have only used, I think, what they say, a small range of here as of now, and it can cover. And that means you can have this for yourself, and then you can have potentially, no matter you have IoT car, I don't think you can have all the way to 65,000 networks anyway, but we can afford to. For now, I don't know about 10 years time. I think still can afford to waste address space in IPv6. But this is the format how they provide global IP address without needing network address translation. Now, if you say, but I still want the ability to have my own network private, that's where this comes in. For your own local only communication, don't use the global unicast address. If you want to control, you don't want the LAN to access internet, don't assign it. They can still communicate because by default, this must be assigned. Link local address must be assigned to an interface. But this link local address is only available in its own link. Will not be forwarded by the router. Okay, so this local, that's why it's can link local. Is that okay?
Okay.
Okay, any questions on this? So straightforward, right? When you look at this kind of format, it's straightforward compared to the convoluted way we have to use IPv4. Okay, so that's why there's a lot of good about IPv6, but the transition will take a while due to the reasons why what I mentioned earlier on, right? Right. So we finished that part. That part, the syllabus for the subnetting IPv6, and that's why for further reading to more understand what's happening between the transition IPv4, what you gain, you can read this request for comments, or you can, if you find, I think I've read this, it's not that dry, it's actually quite interesting. It is done in a conversation way, right? So and it actually makes it it's reasonable the way they think about how to provide other things that the net provides, like the security parts, okay, different areas of IPv6 will support that, right? We also know that to prevent address duplicate in the network, in your own link, there is a protocol running that can detect, okay, and prohibit, because the process of creating the interface ID, right, is also checking other computer within the link whether they already have the ID, so to prevent duplication within your own link, right? So there's a protocol in IPv6, but there's no protocol in IPv4. That's why you can misconfigure IPv4. Um, that's why sometimes if the network administrator is not careful, he reuse an IP address, and then the Windows usually will report with a small message, IP address duplicated, something like that, warn the user. Okay, but there is not. It is passive. There's no active a way to actually find out if the address you are assigning is already assigned elsewhere. In IPv6, remember when you send out the IP address that you want to create, okay, if there's any computer in the network that is online that is actually using the IP address, it will reply back to you, and then you discard that and regenerate. Okay, for Windows right now, it's using random method to generate the interface ID. Okay, but there's another one which is the EUI64 method. Okay, last time Windows used that, but different OS will use different method, different algorithm to create the interface ID. Okay, so that means it makes the job of the RIR easier. They don't have to think about until interface and until the subnet ID. They only need to manage the global routing prefix. That's all. They leave the rest to you. They leave the subnet ID and the interface ID configuration at the customer side. As long as they provide the unique global routing prefix, anything you create, whether the subnet ID and the interface ID, definitely will be unique, right? Okay. Any question?
So
Any
the
question?
interface,
Yes.
so the interface, what IP is
ID.
the unique for each device?
Yes. Unique in
Oh,
the own link. And what makes it unique globally is the global routing prefix. So in your own link, remember, it will be unique because there's a IP version 6 protocol. Okay, I think it's NDP or something like that, to detect, okay, to detect duplicate interface ID. How does it detect? Well, the process of creating interface ID is done, and then before it's applied, the protocol sends out the interface ID to all the hosts in the link. Any host with the same interface ID will reply, and then that interface ID is discarded. Generate another one using random process. Then, but if there's no reply, that means it's unique. Then it will be taken and applied to the computer. Yeah, yeah. And to solve the problem of, well, what about global, the internet, the world? Well, the global routing prefix is unique to you, given by the ISP. And the ISP gets it from the IRR. IRR managed globally. Okay, so definitely you'll be unique because your global routing prefix is belong only to you. As long, I think, I'm not sure, as long, because we still go via the ISP, so that means it's not permanent life lah, you know. Okay, we have this fantasy that, okay, can we have a permanent IP for the, like our permanent my card? I'm not sure that's easy to manage globally. So we still use the old method, where as long as you subscribe to um, the global routing prefix is tied to your subscription to your ISP. It's not a separate process. Yeah, and I don't know what's the criteria for individual applying to RIR directly, because the ISP have to apply to RIR to get, right, to get the range of global routing prefix that they can then rent. I say rent because if you say sell, means it belongs to you already, right? But it's rent in the sense that if you stop using the ISP, then you lose your IPv6 global routing prefix. Okay, this is my understanding how the business work right now lah. Okay, because it's all tied to business again. So what I'm not sure is in this country, how does that work if you want to apply your own global, whether you're allowed to approach RIR directly because you're a normal person, or even if you have a company, or there's a rule saying that you have to get from your ISP, cannot go directly to RIR. Okay, this is under communication thing rule in particular country. They decide. I think the government decide, right? I'm not sure because I haven't read what is the exact ruling on this for IPv6. But I tend to believe that is the rule or the law is different country to country lah. Maybe similar, but country to country different sets of rules. In our country, it's dominated by telecom, right? Our telecommunication infrastructure is dominated by telecom. Telecom is a GLC of the government, and that means every other ISP will get from telecom, and then telecom is not allowed to perform any business. So telecom create subsidiary company like if TMNet is for ADSL services, and then Unify is for cable, for fiber optic services. Okay, other ISP can also purchase from telecom, and then they can sell the access, the infrastructure to their own customer, and that's where the level where the competition exists. But as a sole provider, so telecom is a sole provider at that level, close to the internet backbone, right? And this actually is controlled by government, unless they want to privatize that hierarchy, that level up there, at the level of telecom. Then we have maybe, so there are pros and cons lah. Okay, certain countries they open up until that level, in some countries at the ISP level. Right? Okay, any questions? Any question for chapter 8 in terms of subnetting, VLSM?
So far, no.
Because if we look at what we are actually ahead, so I can answer either I can move on to the chapter 6 network layer, or if you have any questions, I can review back the chapter on subnetting of VLSM. So any feedback from you guys? Sorry about the noise. I think neighbor is doing something. Is it very loud? The banging?
No.
Can hear?
Cannot hear.
Cannot hear? Okay, good. Because I can hear the banging from the neighbor. All right. So anything you want me to go back and maybe review? Let's say from
Maybe the tutorial.
tutorial.
Yeah.
You want to review the tutorial? Okay. Let's just see. Tutorial. So which tutorial you want me to review?
8.1.
We are now up to 8.1. Okay, so 6 we haven't covered. We cover after this guy. So 7 or 8.1.
8.1.
Sorry? 8. 8.1. 8.1, yeah? 8.1 is this one. Right here. Right. The rest okay? Farah and Kelvin?
Okay.
So okay, because later on, then in the tutorial session later, we'll start to cover 8.2. So 8.1 subnetting, class A, B, and C. Right. 8.2 will be VLSM. We'll start to do VLSM. So this is subnetting, right? So subnetting, as I said before, okay, just review back, so we get into our mind what we are doing. So there's a lot of skills you need to know here that you need to know. That means identifying the address given to you, whether it's definitely private address range. Okay, we don't subnet public IPv4 address. We subnet private IPv4 addresses, and private addresses, they come in 3 classes. That means where we start. That's important because we need to know where do we start to borrow bits. So we normally have class A, B, and C, okay, for IPv4. So class A is at the /8 prefix. Class B is at /16 prefix, and class C is at /24 prefix. So depending on the address you're given, for example, in this question, you're given 192. We know that 192 is class C. So it's a /24. Okay. Sometimes they give you slash prefix already, so don't have to look at what class. You just depend on the prefix. So /24 means 24 bits belong to the network portion. So only left one portion for the host, and that one octet is 8 bit. So when you're starting to borrow bits to create subnets, you are borrowing from the boundary at /24 or at the 24th bit. Then you start borrowing into the host. You always borrow from the host bits. Okay, so /24 means you borrow. So the 1 bit you borrow makes your prefix becomes /25. You borrow 2 bits, your prefix becomes /26, because you always count from 24. So you add 24 plus 1. You borrow 1 bit, 24 plus 1, 25, plus 2, 6, and so on. And for class C, the maximum number of bits you can borrow that still leave you with a functioning network is 6 bits. Okay, so that means the prefix, the maximum you can borrow is 6. That means your prefix will be /30. /30 leaves you with 2 bits for the host. Okay, 2 bits for the host means 2 to the power 2 bits. 2 to the power 2 is 4 minus 2. You will get 2 host address, usable host address. Okay, and the smallest number of hosts required for a subnet is for a wide area network connection between routers to router. Okay, with router to router, you need, because the point to point, you need addresses only for the two interface, right? So let's look at this question, right? So normally questions will be given like this, right? You need to know what are the required number of subnets, okay, for subnetting. So please take note where we borrow bits from the 24 bit onwards, okay, /24. And this is the original network address. The prefix also is very important because that tells you how many bits belong to the network part. And if you want to know what is the subnet mask, just convert all the network part bits into ones and the remaining host bits into 0. Convert those binary into decimal, you get the subnet mask. Okay, when you start to subnet, you know, because you borrow bits, there will be additional ones in the host part. Okay, and that means it will change the value. Instead of 0, it will be something else depending on how many bits you borrow. So the new subnet mask will be different from the default subnet mask for that particular address. Okay. Okay. So let's move forward. The school consists of 20 classrooms and 5 offices. Okay. Each classroom each classroom and office require subnet. So that simply means one each for classroom and one each for offices. So 20 plus 5, you need 25 subnets. So that answer, how many subnets are needed? 20 plus 5, 25. Okay. So Farrell is correctly 25 subnets needed. Sometimes they don't give you this. Later we'll see the question. They give you not in words but in diagram. So you need to be able to look at the topology diagram and glean out some information from the topology diagram. You need to be able to read logical topology diagram, right? So sometimes they just give you in words scenario. Next question, how many bits must be borrowed to support required number of subnets? 25. Now I've told you already, you can do the like 2 power 2, 2 power 3, 2 power 4. That method is not really suitable if you're if you have doing class B or A where you deal with larger number, right? So for me, I prefer to use very quickly to get it by log base 2. 25, you type there 25, you get the number of bits required. 4.6, that means 5. We double check 2 to the power 5 is 32. 32 can cover 25. If 2 to the power 4, 16 subnets. So 16 cannot cover 25, right? But 32, the next available one, can cover 25. So 5 bits needs to be borrowed. Is it okay so far? Is it okay?
Sir, all this subnet is connected to one router.
Yes.
Oh.
Well, if you use one router for 25 subnets, I will think that the router will be overworked lah. But can. That means your router at the back, you have to provide at least 25 ports because 25 subnets. Okay. In a real world, you won't. I don't think that is unless you don't have money lah. You don't have the money, the budget. But if you have the budget, you might provide several routers, right?
Oh.
Or you might buy the 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 multi-layer switch. Cisco has multi-layer switch that can perform routing as well as switching. Okay, this is but the routing part is not so capable as that means the configuration is not as like when you have a real router. For budget purpose lah, right? You can buy a multi-layer switch. It has switch part, also routing part. Okay, but if you have the budget, if definitely you have because you're getting 25 subnets, right? That means this is a big organization. Then you might want to use different routers. Okay. If you don't have the budget, you can use one router, then just add the module in the back to provide at least the number of ports available to provide up to 25 connection. Each subnet will connect to the router. Is that okay? Understood, huh? Okay. Right. Because routers connect networks together. So if you create 25 subnets, they need to be connected together using router. So if you only have one router, all 25 subnets will connect to that one router. Okay, so that one router, unless it's very high performance and it got 25 ports inside on it, then yeah, you can use one router. Yeah, it depends on your budget also. Okay, we go to part 3. How many usable host addresses per subnet? Well, we know the host part is 8-bit. We borrow 5 bits. We borrow 5 bits, right? We borrow 5 bits. Maybe it's different color. Blue. We borrow 5 bits. So if we light up the bits, 8 bits, right? We borrow 5 bits. So only remain 3 bits. So 3 bits on the host part, the formula is usable host. Usable host. So 2 power n minus 2, the n being 3 bits. So 2 power 3 minus 2 is 8 minus 2, 6. So per subnet, you have 32 subnets by borrowing 5 bits. Per subnet, you have 6 usable hosts addresses. Okay. This one okay?
Okay.
All right. We go to the part 4. Here we compute the decimal value of the new subnet mask. So because our address is /24, /24 means /24 means network, and host. Each network is 8-bit. add bit here, add bit here, add bit here. Of course, add bit here. But we are interested in the network part. So add plus add is 24 bits. Okay, so to create subnet mask, network part all ones. So 1, 2, 3, 4, 1, 2, 3, 4, that's one. That's 8 bits. 1, 2, 3, 4, 1, 2, 3, 4. That's another 8 bit. 1, 2, 3, 4, 1, 2, 3, 4. That's 3 bits. Three octets. And then the remaining 8 bits cost. But remember, we borrowed how many bits? 5 bits. We borrow 5 bits. So all the 5 bits. Oops. 5 bits, yeah. So 5 bits. 1, 2, 3, 4, 5. Okay. Now belong to the host part. So only remaining 3 bits belonging to host parts. Okay. So this value is still 255. This one dot 255 and dot 255, but no longer 0 this part because we have the 5 bits here belong to network. Now it's all 1. Okay, so this is when you convert this bits here to decimal, becomes 248. So that's the new subnet mask. Originally is 255.255.0 because the original one is /24, but now it's borrow 5 bits. Okay, so 24 plus 5 is 29, so /29. /29 subnet mask is 255.255.255.248. Is that okay?
Okay.
Okay.
Yeah. Okay. All right. So before we move on to part 5, from the subnet mask, what is the last bit position? This is 1, 2, 4, 8. So the magic number is 8. Remember the magic number?
Yeah.
You guys remember magic number? What is it used for? When you're creating the subnet's address, the next subnet address will use you increment by the magic number. You get the next subnet. To get the next subnet, increment by magic number again. And so on until you get the number of subnet. And here is the number of subnets 32. Right? So remember, the last bit on the subnet mask, the position indicates, well, the value of that position in decimal. Okay? Indicates the magic number. So here the value is 1, here 2, 4, 8. So 8 is magic number. Why is that important? Have a look here in the part 5. Okay. We know the first subnet is 0. First subnet, first address is the network address, which is 0. So what's the next subnet address? Well, what was our magic number? 8. What's the next subnet? Plus 8 again. What's the next? 16 plus 8. So dot 24. Right? So that's very important to get the subnet address first. See, 24. Because, okay, so what's the next after 24? 24 plus 8, 32.
32.
Yeah, 32 here. we're not required to list. We only list 4 because the question asks us for 4 initial subnet. Why I want that? Because the broadcast address for the previous subnet is the address directly before this network address 32, 31. What's the next? The previous broadcast number? 24. Previous to that is 23. Previous to that is 16 is 15. Previous to 8 is 7. As long as you get this correct, you get this correct. Then once you get this and this, what's the first usable IP address? The next IP address after the network address, the 1. What's the last usable IP address? The one before the broadcast address for the subnet, which is 6, because it's 7, right? 6. So the range is between 1 to 6. So 1.1.2.3.4.5.6. That gives us the usable host address. So then you proceed to do fill up. Any question?
Sir, so if we want to subnet a subnet, so we have to borrow bits from the host site like that.
Yes, subnet is the topic of the next tutorial, 8.2. Means, let's say I want to subnet. I need to choose which subnet available that I can subnet. Let's say this subnet. Let's just say I'll just drop that off. Let's say I want to use this. So you take this range address from 16 to 23 and subnet it. Borrow bits. So here is borrow 1, 2, 3, 4, 5. So it's a /29. So if I want to subnet that, I can only borrow 1 more bit. That makes it, oh, sorry. And that makes it /30. I cannot go beyond /30 because the network won't be usable. So 1, 1, 1, 1, 1, 0. Or so the extra bit I borrow provide me additional 2 subnet within this subnet. So I can create within subnet number 2, I can create 2 additional subnet /30.
Oh,
Right? You get that, huh? So, and then the magic number is here, 1, 2, 4. 4 is the magic number. So, the subnet within this version is 16 plus 4, which is 20. Okay, plus 4, another 4, 24, which is this one. So, this one I can use, it's part of that. So, the range is from 16 to 20, 20 to 24, 2 subnets. So, still 23 is the broadcast address for 20, right? And then 20 to, the range should be 21 to 22. So the range here is, here you'll change to 19. So the range will be 17 to 18. 2 only, makan? 2 only, 2 usable. 2 usable host address. So that's the subnetting the subnet. I got the subnet 2. Then I subnet it again. But I can only borrow 1 bit because it makes it /30. So I can get within subnet 2 range, I can get 2 additional subnet divided. Each subnet will be /30. So, okay. So this explanation is additional to this question. This question didn't ask. Okay, this one I want to answer the what if I want to do VRSN here. Okay. Yeah.
Okay.
Okay. So next, let's go and look at question 2. Question 2 is also another popular kind of question being asked, but slightly different because it gives you a structured way to ask. It gives you the host IP address. So that means you have to work backward, and the subnet mask. So notice the subnet mask is .240. So it's already borrow bits. Here you're given a subnet mask rather than a prefix. These two are the given, and the one tick is the one that you have to provide the answer. Okay, so because they give you the subnet mask and host address of an already subnetted network, so you have to work backwards. Just now, the previous question, we work with requirement, we get the subnets. Here, we given the subnets, find out back what was it. Okay. So here, how do we proceed is look at the subnet mask. From the subnet mask, you know how many bits were borrowed. Okay. So very easy. Normally, I use calculator, very fast programmer. Just plug in the number in decimal 240. Then you see for the binary part, we borrow 4 bits. Can you see that? So I know the prefix is 20, because this is 24, 192. Okay, you know also that this subnet mask cannot tell you whether original is class A, B, or C. This one tells you 192. That range is class C, so that means it starts from the 24-bit boundary. So we borrow 4 bits. So when we borrow 4 bits from 24 onwards, 24 plus 4 is 28. So this is a /28 network. Okay, so that is a .1111 borrow 4 bits. So number of subnet bits, very easy now. Count how many ones? 1, 2, 3, 4. So 4 subnet bits. Number of subnets, 2 power 4, 16. So 16. Number of host bits per subnet, count the zeros. 1, 2, because host, right? 1, 2, 3, 4. 4. Number of usable hosts per subnet, formula is 2 power n, which is 4, minus 2. Get 14. Okay, so that part is straightforward. The next 4, you have to work your way backward. Question is, what is the subnet address for this IP address? What's this about this subnet mask? Sorry, what is the subnet address? What you're given, host IP address. How do we get address from IP address? The easiest way, we do the ending, right? So we do ending. 210 is 11010010. Okay, so let's just write it down. 11010010. And what is the subnet mask? 11110000. Correct?
Yeah.
This is what the router does. The 255.255 will all give the 192.168.4 anyway. But what we are interested the what is the network address for this IP 210? So you just do ending 00001011. And then once we get that, we just find out what address is that. So we plug it in here, 11010000. So 208. And that's your answer. That's the fastest way to get it lah. Do the ending. And don't forget, network address needs the prefix. So this is slash 28 because 24 plus 4 bits borrowed is 28. All right, so we got that. Okay, the easiest way again to proceed from here, I don't know why. Okay, we go here. Is I solve for me, I solve the what first? I want to solve the broadcast. Okay, so what is the magic number? 1, 2, 4, 8, 16. 16 is the magic number because the last one in the subnet mask is at position 16. So 208, 208 plus 16 is 224, correct? Magic number is, let me just work it out for you, because it's a dot 11110000. So this indicates 16. It's 1, 2, 4, 8. So 16. 16 is the magic number. So 208 plus 16 gives you the next subnet. So 68422. 224 is the next subnet. So the broadcast address for this subnet is one below that, which is 223. Once you get 223, first usable is just the next number of 208. 208 is 209. And the last usable host IP address is the one below broadcast, which is 223, so it's 222. Is that okay?
Because kind of on the subnet address that they use the 13 times 16. So yeah, that's why I confused a bit.
Oh yeah, you can do that as well. You can do that as well. That is alternate way. But another way is using the router way, which is the ending. Because you can the alternate way is you want to find out which network address is this one. So if you use the magic number to add until you get the subnet address. Okay. But you can also use this, which is faster, using router method ending. So okay.
Yeah.
Whichever, both ways also okay. Because to answer this question, you don't need to show the method or the working. No need to show the working. Right? Others okay, not this part?
Okay.
Yeah.
Yeah.
Right. So the magic number seems to be very useful. So remember, write out the subnet mask. Find the last bit. Find the position. What is the value in decimal for that bit? And that's your magic number. And it's very easy to use the magic number to find the next subnet address. Okay, for class C is straightforward, but for class B and A, you need to the magic number works with the second, the first host octet rather than the last host octet. Okay. Right. So we move on to the third question. Okay, with reference to figure 1, that means here the scenario is given to you in a logical topology diagram. So, how many subnets needed? We count. We count. Knowing about the topology, how to do topology is important here. So, we look at the routers and we look at the interface on the router. Okay, so here we have a network connected to the router. Okay, so each interface on a router indicates a network or a subnet. So here is one, so one subnet. Okay, and then between this router and this router, they share this media. So this is another subnet. So two subnets. Similar here, three subnets, and then here four subnets. So we need four. You can see we need four subnets to provide addresses for this topology. How many subnets needed? Four. Right?
So for this topology, with default gateway refer to which one?
Default gateway means the interface connected to that particular subnet that allows the packets to go to the router and out. So when we look at this subnet, the gateway address is only usable by the host. So when we look at let me just annotate. So when you look at this, there are no hosts. I mean, host in the traditional way lah. This is host, but these are for interface. So there are no host these two network. So we don't need to set this as any depending if there's any network here lah. But here we don't have to worry about it. So we look at the ones that subnet that has a host in it, which is this because we have this because we have this host. And this host, if it just communicate within this network, it does not need gateway, right? But the moment, okay, let me just clear first. So the moment that this host need to communicate outside, let's say to this host, they want to communicate. Now to communicate needs to go through router because this router will forward it to this router will forward it to this router, and this router will deliver to the switch, and the switch will deliver to the PC, right? So that means you need to go outside of your own network. So when you want to know for this network, no longer this one, right? Because this is the original network. So just say this network here. Okay, need to go out, right, to this interface. Need to go out through a router. So on the router, okay, the interface on the router that connects to this network becomes the default gateway for this network.
Oh,
So the
for
address
PC,
on
is it?
this interface, yeah, address on this interface becomes the gateway address for this host and other hosts inside this network. Because if they want to communicate outside, they need to go through this interface. So this interface address will be the gateway address for the rest of the hosts inside this network. For this network, they have to go through this interface. So the address here will be the default gateway address for the host within this network. Okay?
Oh,
That's how you first identify for the router that's connected to this network, which interface is it? Then you find out that interface, what is the address of that interface, and that will be the gateway address for that network. Can you have more than one gateway interface? Can you have situation like maybe you have another router? Yes, you may have another router or maybe 3 routers. This is called to provide redundancy, just in case this one go down. But while the 3 are up, also if the 3 are up, you can use these 3 routers to do load balancing. If this is a large network, you want to have three routers to serve this particular network, you can, but you still need only one gateway address. How do you configure that? You use virtual gateway address, and that is a topic in your next course. In the next course, you will learn how to do this, your computer network course. Okay, you do redundancy in terms of router and switches. Okay, so and there will be some kind of issues with that and some kind of extra configuration. So in your not in this network course, but the next network course is computer networks. I think in the syllabus, in your program, the next course called computer networks, you will learn about that. But for now, we assume we only have one router serving your LAN. So that router interface that is connected to you directly, like this one for this network, this one for this network, then those are the addresses set on that interface is the gateway address to be used by all the hosts within that network. Okay, but you only use the gateway address if you're communicating outside of your network. If you're communicating within your network, your message don't even go to the router. Your message go to switch it to the other host directly. Right? Directly. If you want to communicate outside, then your packet will go to the router and your router will forward it based on the routing table information. If communication within your own network, router not involved, switch will be the one that's doing it. Right? Because it's just switch to the host that you want to communicate with. Right? Now, inside your own computer, you also have a routing table. You know that? There's a routing table here in the router, but inside your own PC, you also have your own routing table. We talk about this in chapter 6. Chapter 6. But I can talk about it now a little bit to show you, right? You can type to view it. You can type outprint. That's your routing table inside your PC. Why do you need that? Because to make the decision where to send the packet, if your destination inside your PC, when you want to send the packet, if your PC detect that the network address of the destination IP address within that packet does not belong in your own network, it will send it to the gateway address, which means it gets sent to the router and the router will do the routing. Okay, that's why you need to have the gateway address. If you don't set the gateway address, when the computer sees that the IP address, destination IP address is not inside its own network, it does not know where to send it because there's no gateway address, and it's going to fail. Okay? So, all right, we'll discuss more about this in the chapter 6. Okay, next chapter.
Okay.
Right? So let's move on. Okay. And say how many bits must be borrowed to support required number of subnets? Again, I think this one we don't need to use the calculator here. No need to use this now. You can put, but I think it's very obvious. To get the where is it here? This one. To get how many bits for 4 is, well, 2, right? 2 times 2 is 4. So 2 power 2. 4 is 2 bits. The n is 2. Okay. So all right. You can still plug it in here, no worries. So you put it 2, it gives you 2. Oh, sorry, 1. Oh, okay. 4 bits. 4 bits just now. Sorry. Make a mistake. 4 bits, how many bits may we support the required? No, it's 2. 2 bits. 2 power 2 is, hang on. Yeah, 2 power 2, you need to borrow 2 bits to get 400. No, why this one give me, oh, not 2, 4. We get 4 subnets, so yeah, correct, 2. So borrow 2 bits. Okay. As you can see, if you need 4 subnets, how many bits to borrow? So fill in the number of subnets, 4, you get 2. So 2 power 2 is 4. Okay, so that's why it's 2 bits. Okay, next, how many usable host addresses per subnet? So we know we have 8 bits. We got minus 2 bits. 2 bits give you 6. So 6 bits left for host. So formula usable is 2 power 6. Okay, that's 6, minus 2. 64 minus 2, 62 usable host address. Compute the decimal value of the new subnet mask. Well, it's given here. Original is 255, 255, 255. Now no longer zeros because there's 2 bits borrowed, 1 here. So converting 11000000 give you 192. So that's a new subnet mask. Okay, we borrow 2 bits, so the 2 bits belong to network part. So it becomes, instead of 0, it becomes 11. All right. Okay, next. From the subnet mask, can we find out what is the magic number? Well, the magic number here is, so this one, right? So 1, 2, 4, 8, 16, 32, 64. So this is 64. So magic number is 64. So we always start with 0, plus 64, 64, plus 64, it's 128, plus 64, let me just bring it up. It's 192. 192, 64 is 8, 96 is it 5? 92. No, it's 110, 16, 168. Sorry, no more. It's go beyond already. Cannot. So there is no more. It's only 4 subnet, right? So I was thinking of finding the next one. Only 4 subnet. So the broadcast address for the last subnet is definitely 255. So once you get that, okay, you can get this range 192. So here is 191. Get this range 128. Here is 127, one below, right? And you get this range 64. One below is 63, and then you get this range. So using magic number, fill this up. Okay, but how do you know to stop? Is when how many subnets created by borrowing the 2 bits. 4, right? So that's why I make a mistake just now to add. Actually, it's only up to 4. Okay.
So for the subnet number, we have to count from 0.
Yes.
Oh.
Yeah, because the range is initially is 0 to 255, the single subnet, right? The original one is, this is network, and this is broadcast. And the usable is 1 to 254, the original network, the original single subnet. So when you divide, you minimum start from 0. If you divide some more, still 0 the first one. Okay? Yeah. Even if you borrow 2 bits, you borrow 2 bits, the range will be 0, 0, 0, 1, 1, 0, 1, 1. The rest is just and so on. The one is false. Okay, and the borrow bits is this part. Why we have 4 subnet? Actually, if you do the pattern of binary, yeah, you can create 4 patterns: 0, 0, 0, 1, 1, 0, 1, 1. Okay, so 0, 0, 0, 0, 0, you get that. 0, 1, 0, 0, 0, 0, you get 64. 1, 0, 0, 0, 0, 0, 1 to 8. 1, 1, 0, 0, 0, 0 is 1 and 2.
Oh, I see now.
Yeah. Okay. So it definitely will be 0, the first one, because network address first part is all 0, and the first subnet always, the first pattern is all 0. Okay, and the last pattern is all 1s. Okay, and the last address will be all 1s here. So that's why it's 255. This is all 1. You can see that, huh? All right, so that's okay. We revised this already, subnets. Okay, so before we go on into tutorial where you guys do the 8.2 VSM for VSM tutorial, we'll go for a quick break. Okay. Right.
Okay.
Okay. So I'll stop my recording first. And can we join the other meet? Okay.
Okay.
All right. So I'll see
Who do which part?
Oh yeah, not yet assigned. Hello. So I see that you guys already started to look at it.
Yeah.
Okay, so here is VLSM. So the first question for Farah is to just, this is theory question. What are the two advantages of using VLSM, right? So this one you can find from your slides. What are the advantages? Okay. And question two, now this is VLSM. So you know you got the work together, Noel and Kelvin, work together to discuss how to do this question two. So you can see that how many subnets are available. First of all, look at it. How many from the topology? How many subnets that you need to create? So there's let me just share my screen first. All right. So when you look at it, how many subnets? Well, let me just let's count together. 1, 2, 3, 4, 5, 6. 6 subnets. And then what you need to do VLSM is we name the subnet I, subnet like this lah, subnet I required host for T. So and then sub 2 required host 30, right? 30. And then subnet 3 required host 14, and so on. Then you need to sort them from the largest host requirement to the smallest host requirement. Okay.
So the
And try
subnets.
to, yes, and then try to solve the largest one you can see here is 40 hosts. So you try to solve 40 hosts first. What is how many bits you need to borrow? That still can cover 1, 2, 3, 4, 5, 6 subnet, but the subnet, the slash prefix you choose has enough bits left over to cover 40 hosts. Should be available. Then after 40 hosts, okay, how many bits you borrow for 40 hosts? It means you give prefix. What is the prefix? How many bits you need to borrow for 30 hosts? Give that prefix for the second subnet, and so on, right? And we try to match the prefix to the number of hosts required. Okay, I try first. So after Farah, you finish question 1, Farah. Okay, you do the last one, question 4A. There's no B, just A, right? Hey, hang on. Has recognized an internet link from its local internet service. Oh, it's the same. So again, identify how many subnets you need and order the subnets required. So network B is 120 hosts. So and then network, you only need to provide, I think, yes, the 3 networks and 1 wide area network. Okay, so the 3 networks are network B, A, and C, and the network D for wide area network, four subnets. All right, so then you order the required host from the largest required host first, 120, to the next one, 50, and then to the next one, 30, and then to the last one, 2. Okay, and then you try to provide the network, okay, that gives you 130 hosts. And then what's the prefix and what's the subnet address, broadcast address, first usable, and last usable. And the next one is 50. So how many bits to borrow for 50? Okay, take the second subnet it for 50. Then take the next subnet it for 30, and so on to 30. Okay, so 30 to, and then here the white network here is 2 hosts requirement. Okay, network D is 2 hosts. Right? You guys try it first, and then we'll discuss.
Okay.
Whereas the easiest way for you to do is to sort the network by the largest required host first, going down into the smallest required number of hosts. Okay, so you should start with network B 120, and then work becomes smaller and smaller. Okay, start with network B because it needs the largest required. So you can put network B and then bracket 120 hosts. Yep, hosts, and then the next largest is network A, 50 hosts, and then work down. Okay, then network C, 30 hosts, then network D, 2 hosts. Right? From there, you can then use the subnetting. Okay, for Noel, your first one is correct, but second and third is not correct. And Kelvin, okay, so right. So
Which
it's good if you work together. You work together. So Noel and Kelvin work together because you have to do very similar to what Farah is doing. You have to sort them by required number of hosts. Then you can do subnetting of VSM from the top down. Yeah. So starting with the largest number of required hosts, which is switch. Well, you can call it subnet one or subnet A. Okay. And then going down to subnet B or subnet 2, which is 30 hosts. Okay, give it a name lah. I think ABC is all right. And 30 hosts going to down to 14, 14, then 6, and then from there you start to do the subnetting. You do step by step. Subnet for the first 40 hosts, subnet for the next 30 hosts, and so on. So for Farah, you start with subnetting for the first network first. So how many bits do you need to borrow to get 120 hosts?
So is this correct?
Hmm. No, still not correct. You guys, I think you guys know the prefix, but the network portion, remember that, okay, you cannot overlap the address range if you have already allocated an address range to a particular subnet. You must start to subnet from the next range, available range. Okay, or else you are taking address from the previous subnet. So for example, I can see that from Noel, okay, uh, dot 64/27. Okay, that one is correct already. Ah, correct already for Noel.
Oh, actually,
Okay.
it's Kelvin. But why 64, sir?
Oh, because if you bit, right? When you borrow 2 bits, that means uh, a magic number is at 64, right?
Yeah, full
It
64.
should-
There would have to
Yeah.
be 64 also. All of them must be used. And,
Yes. Yeah.
and
For
then
the dash 26, we use all 64. So
and then
the next subnet you need to work on, whether it's for VSM, must start from, yeah, the next subnet, or else you will overlap with the previous subnet. Okay. So correct. The 193.360.26 means you borrow 2 bits. 2 bits give you 6 bits for the host part to cover I guess, the 40 hosts, right? Now, the magic number is at the 64 position. So 0 plus 64, the next subnet available to subnet is 64, starting from 64. So at 64, to provide, I think, 30 hosts, right? You you borrow another, uh, I think 1 bit, yeah, 1 bit leave you 5 bits host. Okay, cover 30 hosts, right? So now the magic number pindah already, from 64 to 32, right? So 64 plus 32, okay. So imagine that the next one is 33, 14 hosts, not hosts. So 64 plus 32 is 96, right? Correct lah. You start from slash 28 at 96. Slash 28, you borrow another bit, is at 16, right? So 16 plus 96, the next available subnet is 112, I guess. Is it 112? Yes, 112, right? Because you need 16, also because it's also 14 hosts. So 112 plus 16 gives you 128. Okay, and 128, you borrow 1 bit more, 29. Correct, yeah, 128. So the next bit is at position after 16 is 8, right? So 128 plus 8 is 136/30. Is that all right?
Right.
So using the magic number, you can work out the subnet addresses. The next subnet address available for you to submit. Okay, so that's now everything is correct already. Yeah. Okay. Right. So I think Farah is having a little bit of problem, right, Farah? So to get 120 horse, how many bits do you need to borrow? So when you borrow bits, it's on the it's on the network part, right? So the network part, you get okay. First of all, let me just share my screen. For 120 bits, you need 7 bits at the host part, right? At least seven. So because two power 7 gives you 128, which can cover 120. Okay, so if you borrow 7 bits, sorry, if you allocate 7 bits for the host part, you only borrow 1 bit. Okay, hang on. Let me just share my screen. Okay, so for Farah, okay, so requirement is 120. Okay, 120. You plug in here, you get 7 bits. Okay, so 8 bits minus 7 bits for the host part, 7 bits, then you get, so the network part is borrow 1 bit. So 24 borrow 1 bit is 26. So the prefix is /26. Okay, /26. So yes, the first address will always be 0. Okay, so you don't have to write the prefix there. Okay, why 26? Because you borrow 1 bit. If you borrow 1 bit, the host part left 8 minus 1, 7 bits. So 2 power 7 gives you 128 minus 2, 126, which can cover requirement of 120 horse. Right? So when you borrow 1 bit, the what do you call this? The magic number is at the 128 position. So at 128 position, okay, you means you borrow something, you plus, so plus 192.168.16.128. So you have to start from 128. Okay, so when you get 128, here it will be 192.168.16.127. When you get there, 127 means here is 192.168.16.1. Next one is 192.168.16. One below broadcast address 126.
So for network B, isn't the subnet host supposed to be /25?
Oh, oh yeah, 625. Sorry, 25. Sorry. Okay. Now then at network A, 50 horse required. 50 horse required means just plug in here how many bits required to provide horse part. So 6 bit. So if 6 bit, that means 2 bit borrowed. That means 20. Hang on, A 50 horse 26. Yeah. Okay. So that means 26. You left 8 minus 24, 26, 8 minus 2, 6, 2 power 6. 2 power 6 is, what do we get? Is it able to cover? I think it's 60, right? 62, yeah. So can cover 50, right? So the 1 and 2 is because now the magic number is at the 64 position. So 16 plus, sorry, 1 to 8 plus 64 should be 1 and 2, right? Then this one borrow, yes, borrow another bit, it becomes 27. So 27 is look at the 30, 32 plus 32 is 2, 2, 4, right? So once you get this, you know here at the bottom, at the back is 192, 68.255. Hang on, because we have multiple, not only, so it's 224, 225, 226, 227, right? 227, because the next one is slash 30 is plus 4, right? 124, yes, plus 4. So plus 4 is
227 exists.
yeah, 227
One,
actually, but because magic number now is 4, 224 plus 4 is 228, so the broadcast is 227.
is it possible to subnet 30? Is it possible to borrow 31?
Not possible. 31 means you left one bit.
Or
So yeah, only two. So both address will be network and broadcast. There are no host address usable. So no host address cannot use, because there's no host to communicate from that network. Yeah. So here just 225, right? 16.225, because one after 224. Here, because there's only two, so you can see that it's 16.226. Correct? 226 and 227. Yeah. Now here,
is,
yes, sorry.
oh, never mind. Okay.
All right. So Farah, you can now can you complete to get the broadcast address first? The broadcast address is one below the next subnet address. Okay, so the network A first usable host will be the next address after the subnet address. Address is 128. The next one is 192.168.16.129. Yeah. So now we work with the broadcast address first. The broadcast address is the one below network C's address. So if network C is 192, the broadcast address for network A will be 191. Yes. So now the last usable host is one below broadcast. So 190. Okay. Same for the network C. Broadcast address is one below network D subnet address. Yeah, and then last usable host will be one below broadcast address. Yeah, correct. So now we have all correct. Okay, so you guys have the workbook, VSM workbook to work on. Do more exercises in the VSM workbook. There's also some examples there to to master this subnetting and VSM, right? Okay, the more you do, the better you get at it, and the easier it will be when you are answering. Okay, so I hope
In the
that by
final exam, will there be a lot of these kind of questions?
at least minimum one, maximum two, because there are other topic. But if you know how to do this one, you're guaranteed that the mark.
Yeah, 3 marks, right?
3 marks like that. Yes, correct. Yeah. Sometimes you can get up to 8 marks or 12 marks just doing this. Okay. So this one is if you can do it, it's like 3 marks lah, score lah. Right. So that's why. And the other thing is because SBA, you are required to do VSM as well. SBA. So the marks for the coursework for SBA, there's a VSM question as well. They're very similar to this, what you're doing, right? So again, you can score there as well, okay? Right, so the only way to get better is do more and more exercises. So if not, there's more exercises in the workbook that I shared with you guys. You can do the workbook, complete the workbook. The more you do, I know minimum 15, I said, but if you have time, I know you got other classes, but if you have time, you can do more exercise there, then you'll improve. Okay, as I seem starting to see that you guys are getting the hang of it, right? And start to do better. All right. So thank you very much. I think that's it for today. All right. So we completed is 8.2 as well. So before I go, for Farah answer question 1, the part 2 is not very accurate. The answer is actually more related to IPv6. You know, it's not actually VSM is not done in IPv6. Okay, so VSM is not done for public networks. VSM and subnetting is done for private networks only. It's only IPv6 that we start to use subnetting for public, just to provide the subnet. So, but the first answer is correct, to reduce the number of wasted IPv4 addresses. And another 2 alternate answer. So because we need 2, right? But we have 3. First one is to reduce number of wasted IP addresses, correct, from this Farah. And grouping together similar devices. That means if you just mention why you group, it's easier to control or to manage access to devices, because similar devices in the same network, or organization can set the networks based on their division, can also, right? And reduce the size of broadcast domain is another one. Okay.
Okay.
All right. Thank you, everyone.
Okay, sir. Thank you.
Okay. Thank you.
Thank you.
Okay. Bye.